Yeah, comes on everyone. Let's start off. Great. The last thing we did was this kinetic energy. Let's go ahead with the question. Let's say we have block of mass m. The other side we have a ladder whose length is L. Here we have a person of mass m. Mass of the ladder will be m minus n. So system is in equilibrium. So this total mass is m, this mass is n. So find the distance moved by the center of mass when the man climbs to the top of the ladder. Now, if he starts climbing the ladder, what will happen? The ladder will be pushed down, the man will go up. Now, in this, there is an external force on the system. Find distance moved by the ladder, moved by center of mass. Then man climbs to the top. Initially, system is at rest. Question is clear, everyone? Others, do keep your cams on. So the mass of the block is capital M and the mass of the man is small m and the ladder is capital M minus small m. So if he's not moving, both the sides the weights are balanced. How do we approach? Right, Purusa. See, there is only one formula you know. Delta x center of mass is m1 x1 plus m2 x2 by m1 delta x1 plus m2 delta x2 by m1 plus m2 by this thing. So end of the day, what you're interested is actually the change in center of mass. You don't want the actual positions and stuff. So look at this scenario here. When the man starts climbing up, Let's say let the ladder comes x down. Distance moved by ladder. If this thing comes x down, how much will the block go? It will go x up. And how much did the man actually walk? The man actually walks how much? L minus x, isn't it? He will climb L up, but the ladder has come down L. Is that fine, everyone? So delta x center of mass or delta y center of mass in this case is m1, x1, m2, x2. So the block M displacement is x. Man ka mass is small m, displacement is L minus x. Ladder ka mass is m minus m, and the displacement is minus x. By total mass is m plus m minus m plus m. So that is mx by ml minus mx minus mx plus small mx by 2m. This will cancel. ml by 2m. You cannot find what is that x. We cannot find how much is that x, but we know when this man goes up, center mass will move at this much distance. Again, how did you do? We said let the ladder come down by x. Because the ladder is coming down by x, the block has to go up by x. Why? They're connected by a string. In this process, what did the man do? The man climbed up L, but the ladder came down by x. So the net displacement of the man is L minus x. This is the displacement of man. There, you put it in the formula. So delta x center of mass is m1 delta x1 plus m2 delta x2. So in this, if you see the system, there are external forces. Can you see the string here? This is an external force. Since there are external force on the system, center of mass will not remain at rest. Till now, in all the problems we did, there was no external force, so center of mass didn't move. But here in this case, there are external forces, so it does move. Clear, everyone? It's a good one, decent question. Not tough, but you should know what is happening there. Anyone not convinced with this? Next one. Next one. We have a toy train. This is your top view. This is your semicircular toy train. Moving in a circle with constant speed u. So this guy is going with speed u. Mass is m. Radius is r. So half of the track is filled with the train only. Find velocity of center of mass of the train. Find velocity of center of mass and acceleration of center of mass. Remember, every point on the train, because speed is same, but velocity is different. Velocity is tangential like this. So you can't directly add it up. Find the velocity and the acceleration of the center of mass of the train. Is the diagram clear? I know I draw it a little weird, but I hope you got it. It's a toy train. Right, Ansh. Nee, Vihan. So, according to your logic, if one particle goes with you and one particle goes with you, velocity of center of mass is you. Let's see. For this train here, where is the center of mass? For this train here, center of mass is somewhere here. So as the train is going, isn't the center of mass also going in a circle? If the train is going in a circle, center of mass is also going in a circle whose radius is 2r by pi, isn't it? So what remains same for both of them? Angular velocity. They cover same angle in same amount of time. So center of mass moves in a circle of radius 2r by pi. They cover same angle, center of mass and the train cover same angle in same time. That means they have same angular velocity. Therefore, omega is same. So omega will be u by r for the train. This is also the same for the center of mass. Therefore, velocity of center of mass will be r omega, r center of mass into omega, which is 2r omega by pi. But what is r omega? U, 2u by pi. Since the center of mass is going in a circle, it will have centripetal acceleration. How much? Omega square r, which is u square by r square. R is 2r by pi. 2u square by pi r. Check. Since it is going in a circle, it will have a centripetal acceleration, which is v square by r, or omega square r, where r is the radius of the circle in which it is going. Easy, making sense. So once you realize it is going in a circle, it suddenly becomes easy to solve. Or else you have to integrate and do a lot of nonsense. It becomes quite messy. Sure, everyone. Clear, Ansh? Got your mistake? Next one. Any doubts on this? Next one. We have an explosive or a bomb of mass m here. So it explodes into three pieces. of mass m by 4, m by 4 and m by 2. So one m by 4 moves along x-axis. Another m by 4 moves along y-axis. Find velocity of m by 2 and the total energy released. Moves along x-axis with v. They're going with speed v. Yeah, speed is given. Yeah, get me the vector form now. I asked you for velocity. No, Abhinav, that is wrong. Right, Vihan. Get it. This is an easy one. I'll give you a minute more. Right, Ishana. Right, Puruja. Got the velocity part. Now, see, the idea in this kind of problems is this. Since explosion is due to internal forces, hmm, right, and internal forces do not change momentum. So now we are slowly, center of mass, we are entering the momentum part. Do not affect center of mass. Therefore, momentum is conserved. So look at the scenario here. So when the bomb is here initially m, this is your initial state, state 1. Your initial momentum is 0, no one is moving. After explosion, one piece m by 4 goes with v. One piece m by 4 goes with v, and another piece m by 2, we don't know, let's call it v bar. So the final momentum will be, remember it's a vector quantity, m by 4 v I cap, m by 4 v j cap, m by 2 v bar. Since there are no external force on the system, p initial is equal to p final. That would be 0, m by 4 vi cap, m by 4 vj cap plus m by 2 v bar. So v bar will be minus v by 2 I cap plus j cap. This goes in the third quadrant. The energy released will be kinetic energy final minus kinetic energy initial. This is half m by 4 v square, half m by 4 v square plus half m by 2. This speed will be how much? V by root 2 square. This thing comes out to be around 3 mv square by 8. Now be careful in this thing, we are neglecting any heat, sound and all, we are doing that. Technically, it releases more than this. Because during an explosion, there is a heat, there is a sound and all that stuff. We are ignoring all that. We should definitely get more than this. It can't be less than this. That much we are sure. Clear? So who told you internal work done by internal forces is 0? We already learned that. I never taught you that. Who told you work done by internal forces is 0? नहीं बोल रहा हूँ कहीं पे तो सुना होगा ना. What is work done by internal conservative forces minus of potential energy? It's not 0. Internal forces can do work. They can't change momentum. Clear? It's like take your hand and punch yourself 10 times. You get tired, you feel pain. See, you did work on yourself. Clear this? Next one. We have an explosive, mass m, projected with speed u and theta. As it goes here at the highest point, it explodes into 3 pieces. Of m by 3. So one m by 3 goes up with u. Another m by 3 retraces the path. So one m by 3 goes up. The other m by 3, we have no clue what it does. We don't know. So the question is, find the velocity of the third piece. So one m by 3 goes up with u. One m by 3 retraces the path. Let's do one thing. Let's take the values also. Take u is 22 meters per second. Take theta is 45. Let's say this thing goes up with 10 meter per second. Let's keep it simple. So this m by 3 goes up with 10 meters per second. The other m by 3 retraces the path. It just goes back to the initial point of projection. Find velocity of m by 3, the last piece. Just after explosion. And find the position where it lands on the ground. Is the question clear? So this mass m goes to the highest point and it explodes. That you need to figure out, Abhinav. They'll not give everything. They just said it'll retrace the path. Now you figure out, so how do we start from there? Okay. Speed is fine. Get the position. Where will this land on the ground? There is an easier version of this question. We'll see that later. You need to give me speeds, Ray. Arya. You can't tell me the magnitude. The speed is easy. See, at the highest point when it is exploding, what is the speed here? This is mass m. This guy is going with u cos theta, which is 20 root 2 cos 45, 20 meters per second. This is just before explosion. Just after explosion, we have one particle m by 3 going with 10. Now tell me one thing, if it is retracing the path, means what? The particle, the way it came back, it went back the same way. Means it must also have a speed of u cos theta, isn't it? Is that making sense? Since it is retracing the path, so it should have gone back with the same velocity it must have come. Since it retraces the path, the particle goes back with the same speed it came. Because the height is same, everything is same, so just need to go back. U cos theta is 20. And the third particle, we have no idea. Let's call it V bar. Initial momentum is equal to final momentum because explosions are internal. Initial momentum m into 20 I cap. Don't forget the vectors. M by 3, 10 J cap. M by 3 minus 20 I cap because it is going backward. M by 3 V bar. M gets cancelled, cross multiply, that will be 60I. So V bar is equal to 60I plus 20, that will be 80I. And minus 10J. Check. That's your velocity, everyone. So this guy is going forward with 80 and going down with 10. Please check your calculations. Most of you didn't get this. I think the only person who got this was Vihan. Someone did get it and they cancelled it. Okay. Others check. Most of you got 20I and all that stuff. So range you got 120. Ansh. Itna अच्छा answer आया? Maybe I was expecting something bad. How to do from here? Now this question becomes simply a projectile motion, throwing a stone from a building. Please have a look at this page. This is simply conservation, just like energy, initial state, final state. We are conserving momentum. 97.88. Devansh is like very ditto, decimal tak answer. 80 root 5, okay. I hope you guys didn't use root 2h by g for time of flight. That is not valid. Now see, the question has become like this. So as this is flying here, at this point when the explosion happens, this is what H max. How much is that? U square sine square theta by 2g. That is 20 root 2 square. That is 800. Sine square 45 is half by 20. This is 40 meters. 20 meters. So this question behaves like this. As if you have a building here, 20 meters ka building. This particle here has speed. In the horizontal direction, ux is equal to 80. Vertical direction, uy is equal to minus 10. And this is flying like this and falling on the ground. Isn't that the question? How do you find time of flight? S vertical is u vertical time plus half a vertical t square. S vertical is minus 20, u vertical is minus 10, minus half g is 10, t square, 10 will cancel here. This will be t square plus 2t minus 4 equal to 0. Yeah, that looks right. And then the time will be minus 2 plus root over b square 4 plus 16. That will be 20 by 2. This is minus 1 plus root 5. That is your time of flight. What is range? Horizontal velocity into time of flight, which is 80 into root 5 minus 1. That is the range from where? From the point of explosion. If you ask me from the initial position, then we have to add this distance also. This would be r by 2, half of the range, where range is u square sine 2 theta by g. U square is 800. This is 10, so this is 80 meters. So from initial position, it is 80 root 5. Who got that? Ishana, you got it. From the point of projection, this guy will go 80 root 5. From the point of explosion, it is 80 root 5 minus 1. Please check this thing. What did you guys do for the time of flight? You took root 2h by g, yeah? Is this making sense? So this guy will have both a horizontal and a vertical component. So it becomes like a projectile which is thrown down. Ask me if you're confused.
Sir, can you just show the previous page?
Clear, everyone? Now, a simpler variation of this question, a mains level question, would be like this. A particle of mass m is projected with u and theta. At highest point, it explodes. Into two equal pieces. If one piece retraces the path, find the position where the second piece lands. Similar one, that is three pieces, that is more complex. One is going up, left, and all. This thing is one piece retraces the path. Generally, in the options will be like that only, from the initial point of projection, from the point of explosion. They'll mention that, but let's find from initial point of projection. There's a much faster way to do this. I will teach you that. No, that is not the answer, Purocha. Meaning from the point of projection, na? Answer you can give in terms of r, where r is u square sine 2 theta by g. I thought you guys will tell this answer like this. Okay, try. Right, Vihan. Oof, Nishana. 3u cos theta root r by g. Why did you take r there? Isn't it root 2h by g? You tried multiplying with the height, right? Time of flight, na? That's root 2h by g. Now listen, there is a much faster way to do. So when this particle is projected with u and theta, as it goes to the highest point, it explodes. So my question is this: since explosion is internal, the center of mass is unaffected. Make sense? What is the meaning of that? The meaning of that is, even if there's an explosion or there's no explosion, the center of mass will continue in the same path. That is, center of mass will continue in the same path. Even if there is no explosion, or if there is an explosion or no explosion, center of mass doesn't care. Agreed with that? So the center of mass should simply go here and land. This is your path of center of mass. So the center of mass will land at 2r comma, r comma 0. Now you're telling me after explosion, one of this particle goes back and retraces the path. So this guy lands at m by 2, which is 0 comma 0. And the other particle here, which goes forward, it goes and lands somewhere here. Let's call it x comma 0. So using this logic, can I say the center mass of this particle plus this particle must be this only? Yes. And which will be, so x center of mass will be m by 2 x plus m by 2 0 by total mass m must be r. X is 2r. It's basically the midpoint. Center of mass of the m by 2 pieces must be at r comma 0. This is easy, faster and easy. But tell me one thing, can I do that here? If that was easy, why didn't I do that here? Option A, teacher forgot. Option B, teacher wants to harass students. Option C, it doesn't work for some reason here. Option D, teacher also don't know. What do you guys think? So what is the reason? Why didn't I teach you this year? It doesn't work. Why doesn't it work? What is the catch? Think, I'll give you 30 seconds. This method, what I taught, this looks pretty easy, right? I can just figure out and finish it off. Oh, itna velocity, momentum, all this story, right? I did was not necessary. But it doesn't work here. That's why I couldn't do it there. No, it's not about lengthy. One particle goes upwards. So what is the problem? Centromers doesn't care, right? No, it doesn't matter, Napuruja. When it explodes, let the particles go in all directions. The centromers is still unaffected, right? Even if the bomb explodes into 1,000 pieces and goes in every direction, the center of mass will continue in a parabolic path. There is no problem with that part. Something else gets goofed up actually. Think, take 30-40 seconds, aram se socho. It's okay if you don't click, but the point is that you thought about it. That idea is important. If someone can, did you figure it out? You have a solid reason, tell me. It works here, but it doesn't work there. Why? Like what just said, it is going up, fair enough. So that does something, but what is it? It's like what just if I ask you, right, why does the fan work? Because I switch on the switch. You know, that's not what I'm expecting from you, right? I'm expecting like what is the principle behind the fan working, and you tell me when you switch on the switch, the fan rotates. That's why I said, yeah, that's not what I mean. What do you guys think? The Vy is changing. Nah, that has nothing to do with it. Think about it. In the previous question also, because this guy went up, to compensate this guy went down. Did you see? Poroja. So Vy compensated. The catch is this. This method, what we did, right, Ahna, you got it. All of them don't land at the same time. This is valid when all land at the same time. What's the problem if you don't land at the same time? The problem is this. So when this thing is flying, and let's say this thing explodes into like 3-4 pieces, so all are going in all directions, no problem. The centromers will still follow the same path. Now tell me one thing, in all these particles, what is the net force acting on the system? Mg, right? Even if it breaks into 1,000 pieces, the total force acting is mg. But let's say one piece lands on the ground. Now what will happen? There is a normal reaction on this particle. Isn't this an external force on the system? The particle which lands on the ground first will stop, or there will be an external force due to the ground. Suddenly on your system, there is an external force on the system. Center of mass will not follow the same path anymore. Momentum is not conserved anymore. Is that making sense? Even if one particle lands on the ground before others, suddenly there is an external force on the system, which is normal reaction on the ground. The center of mass will not follow the same path as before. That is one way to say. Another logic, dekho. If all the particles are flying, what is the acceleration of center of mass? m1 minus g, m2 minus g, so on by m1 plus m2 plus mn, right? All m will cancel, you'll get minus g. But let's say if one particle comes to rest, then what will happen? m1 minus g, m2 minus g, let's say m3 comes to rest. Now it is m1 plus m2 plus m3. Did you see what happened? Acceleration of center of mass is not minus g anymore. Is this point clear? So be careful before using this method. This method will work only when you're sure all of them are landing on the ground at the same time. If they don't land on the ground at the same time, you don't have an option. This is the only way to do. You conserve momentum, find the velocity, and then treat like projectile. But this would be a decent mains level question or a bits level question. So saves you time in the exam. You want to do it that way, I can show you that also. See, that's also not that tough. At the highest point when it explodes, its velocity is u cos theta, mass m. After explosion, one piece m by 2 goes back with u cos theta. The other piece will go m by 2 v bar. Conservation of momentum, mu cos theta minus m by 2 cos theta minus m by 2 v. So we get v is equal to 3 by 2, 3 u cos theta. Now think about this logically. For u cos theta, you travel r by 2. For 3u cos theta, you will travel 3r by 2. The total range is 2r. Is that making sense? So I can do that way also. Momentum thing always works. Center of mass thing will work only if they both land on the ground at the same time. But keep that in mind. Clear? Any doubts on this? Any doubts? All clear? Next one. So it's important you know when things work and when things don't work. So we have a wedge here. This is a wedge with a circular track. Mass of the wedge is 2m. There is a ball here of mass m. All surfaces are smooth. Ground is smooth. Surface between the ball and the wedge is smooth. Everything is smooth. The ball is gently disturbed and the ball starts rolling. A is the bottommost point. Find the speed and the normal reaction when the ball reaches A. This would be an advanced multiple choice question. The same question again, we'll do it in rotational mechanics. That will be a deadly one. Find the speed and normal reaction when the ball reaches A. Think how to do. Take 2-3 minutes, figure it out. You need the speed of the ball or the wedge. Find speed of both of them, no? If I don't tell you, find both. Now, let me tell you something. Now, the thing is, as we are going ahead with this thing, you can see more and more chapters are piling up. So it actually starts becoming a little confusing, like, yeah, what to use and when to use what. Radius of the wedge is given, it is r, I forgot, sorry. So now listen to this carefully, everyone. This is important. This puts a setting for us, as we go ahead, as more and more chapters keep piling up. This is the thing which you should this algo will keep developing itself. So when you get a question, luckily in physics, right, we have only, at least in mechanics, we have two big weapons. We have only two weapon sets. One is your force and torque equations. Torque we still didn't do. That will be the next chapter, rotational mechanics. This is one set of weapons you have. The other set you have is conservations. This is your second tool that you have to solve problems. Now, the first thing is, how do I know should I use force and torque or should I use conservations? The hint is there in the question. If you look at the question, right, the wordings will be like this. Find speed, find maximum height, right? Or find elongation, find compression. You're getting it? Or something like, it is always, if you look at these words, right, it is always about some final position. Means I don't care what is happening in the middle. I just want you to find the speed there, find the position there. Something like, if you look at this previous question, I want you to find the speed at A. I don't care what is happening in the middle. So when you hear these kind of words, generally, maximum, right, 99% of the time, it is conservation. When to use these things? If here you'll hear the words like find tension, right, find accelerations, right? If they say find time. Now, when you hear these kind of words, right, find a normal reaction. Again, maximum is talking about, use force and torque equations. Then what to do? So if you have to use force and torque equations, step one, we have to draw an FBD. Once you draw an FBD, calculate forces, torques, apply constant equations. This becomes purely your NLM and all those chapters. And then apply F is equal to MA. For torque, we will say torque is equal to I alpha. We will see that later on. You apply these equations and then you solve. But if I say conservations, draw the final diagram. So clearly show the diagram. How does it look in the final state? Most of you are not listening, meaning you guys don't feel like you don't need to listen. You know everything. Good to know that. So when you draw the final diagram, you have three options here. One, either you can conserve energy, or you can conserve linear momentum. So this is your second conservation we learned. The third is angular momentum. This we'll be doing in the next chapter. So when you're trying to solve a question, right, generally this is what should go in your head actually. At least this is what I do. If you give me a question and if I have no idea what the hell is happening, I will try to follow this algo. This works for almost 90-95% of the problems. There are always exceptions. Now, when do you conserve energy? To conserve energy, work done by external must be zero. When do you conserve momentum? When external force is zero. When do you conserve angular momentum? When torque is zero. So once you got this, solve the equations. So if you see any problem in mechanics, either it will fall in that category or this category. Now, if you look at our question, you want to find the speed at A. It is clear I have to conserve. So draw your final diagram. So initially it is here M. This is 2M. Everything is at rest. So after some time, this guy is going with V1. This guy is going with V2. There's no guarantee they'll have same speed. So let them go in the opposite directions. This is V1 and this is V2. Now I know I have to conserve momentum. I have to conserve. So check what can I conserve here. If you look at the system, horizontal forces are zero. Be careful. Vertically, there is a normal reaction on the ground and mg is there. There are external forces in the vertical direction. So in this system, horizontal forces are 0. Therefore, only horizontal momentum is conserved. So you need to check, is the force 0, is the work 0, is the torque 0? Therefore, horizontal momentum is conserved. So initial momentum is equal to final momentum. What is initial momentum? 0. Final momentum mv1 minus 2mv2. Signs are important. v1 is equal to 2v2. This is your first equation, everyone. Next thing, since there are work done by external forces is 0. Since work done by external is 0, energy is conserved. So generally when you use conservations, right, you will get at least 2 conservations. That will help you to, solve. Now, these are the things, you will learn when you practice and do things. So loss in PE is gain in KE. See, I'm solving all this without any FBD and stuff. So how much energy did you lose? MGR. Only the ball is falling. What is the kinetic energy gained? Half mv1 square for the ball. Half 2mv2 square for the wedge. v1 is equal to 2v2. So this will be GR. This is half 4v2 square plus v2 square. So v2 is equal to root over GR by 3. And v1 is equal to 2 times root GR by 3. There, that's how you get your velocities. Please check your steps. Now, second part of the question, what did I ask you? Find normal reaction. Now, if you have to find normal reaction, what should I use? I should use my force part of the algo, isn't it? Means I have to draw an FPD. Now, that's what I'm saying, when you have a proper process and steps in the hand, right? In the exam, even if you're under tension, your brain knows what to do. You getting it? It is like a habit. So that is what you should develop actually. That is the reason I keep teaching you with steps every time. Question is not over. How do you find normal reaction? Try, I'll give you a minute. Four mg by 3. Okay. I don't know the answer, but I don't think that is right. Let's see, maybe could be right also. Anyone else got 4 mg by 3? We have one answer, which I'm quite suspicious about. The normal reaction is a really good one. 7 mg by 3. We have one more answer. We have two 4 mg by 3s. Two mg. We have two 7 mg by 3s. We have two 4 mg by 3s. Let's see. Let's see, did you goof up or not? I like to ask you again, what is acentripetal? Now here, if you look at this ball is going in a circular track. So when you write the forces, we have normal reaction. We have your own weight mg. Since you're going in a circle, there is a centripetal acceleration. And this guy is going with v1, the wedge is going with v2. What is acentripetal? Acentripetal is v relative square by r. I hope you remember that. In this case, the center is moving. The center is not at rest. So this is actually V1 minus of minus V2 ka square by R. In case you forgot this, we did this in circular motion. Page question 17. The person who thinks it is going in a circle is the wedge. So when you stand on the wedge, you think it is going in a circle. So the speed must be with respect to the wedge. It is not the velocity in the ground frame there. Quite an important one. A centripetal is V relative square with respect to the center by R. I will put that there to check it out. Page 55, circular motion. A is not V square by R. That V is the velocity with respect to the center. That is a trap in the question. So N minus mg is equal to mass into centripetal acceleration. So N will be mg plus m into V1 plus V2 square by R. V1 plus V2 will be 3 root 3 gr. So that would be root 3 mg, 4 mg. Did you guys take mv1 square by R? Kya? You forgot the V2 part. Please check. That's a pretty good one. This is, this part makes this question advanced. Any doubts on this? Please ask me. It's a pretty good problem. You can see how many things are there. We have momentum, we have energy, we have circular motion, we have your NLM, 4 chapters. Clear with this? Any doubts on this? Let's see one more. How did you guys get 4 mg by 3? What goof up you did? Next one, say. We have a rod here, horizontal rod. We have a ring, mass 2m. It's a mass m. This is connected by a string. This is 3m. This is a string of length L. You release this from the horizontal position. Then what will happen? This ring will not remain there. Ring will come like this. The ball will come like this. Why are they moving? Because of the tension in the string. And eventually, the string becomes vertical like this. At this point, they will be going with velocities v1 and v2. So find the velocity of the balls and the tension in the string when it becomes vertical. Find velocities, both of them, and tension when the string becomes vertical. Didn't take relative, and we forgot mg also. Okay, happens. When string becomes vertical. Let's get this. Did you get the diagram how it is? The ring is going left and right, and this ball is oscillating like a pendulum. So the point of suspension is not fixed anymore. How do we approach this? Hmm. Root GL by 12, root 9GR by 2, root GR by 2. Wow. Story is the same. One thing is clear, you're asking me find the velocity when the string becomes vertical, means you don't care what is happening in the middle. Indirectly, you're telling me, boss, conserve energy and stuff. So, state 1. This is my state 1. This is my state 2. Be careful. Horizontal forces are 0. Vertically, forces are not 0. Why? Mg is there, and यहाँ पे ring पे normal reaction is also there. In the vertical direction, you can't do anything. Horizontal forces are 0. Therefore, horizontal momentum is constant. Initial momentum is equal to final momentum in the horizontal direction. Initially 0, finally mv1 minus 3mv2. So v1 is 3v2. Second thing, work done by external force is 0. Loss in potential energy is equal to gain in kinetic energy. The only one losing potential energy is the ball. This guy would be 3mgl. 3m is falling now by distance L. So that is your loss in potential energy. That would be half mv1 square plus half 3mv2 square. v1 is 3v2. Substitute here. M goes off. Half v1 will be 3v2 ka square plus 3v2 square by 2. That is 9 plus 3, 12, 6v2 square. v2 is equal to root gl by 2. v1 is 3 times root gl by 2. Right. Who all got root gl by 2? You're right. Yeah, root 9 is also right. 3 comes out. Please look at the steps. This is same thing like the previous one. What about the tension? We have 27 mg and we have 20 mg by 12. For some reason, I feel it is 27 mg. How do you find the tension in the string? Get that. So this and the previous question, what makes it interesting is that normal reaction and the tension. Because these things are going in a circle, but your center is not at rest. That is a catch in these questions. Let's see. You're asking for tension, then I have to draw a free body diagram. What are the forces? Tension, 3 mg. You are going in a circle. Again, be careful. The moment you use the word you are going in a circle, you're not in the ground frame. This is not going in a circle. A person standing on the ring, he will think it is going on a circle, isn't it? Because if you look at in the ground frame, this is what is happening. The ring is going forward, this is coming down. Your motion is pretty weird. You're going in a circle and you're also traveling horizontally. You are going in some weird path. So ring thinks ball is going in circle. You have to stand on the ring and solve the problem. But my ring itself is going with V1. This guy is going with V2. Again, the same thing. So A centripetal will be V1 plus V2 whole square by L. So we have tension minus 3 mg is equal to 3m into A centripetal. So be careful with the centripetal thing. So this is 3 mg plus 3m. V1 plus V2 is 8 GL 8G 27 mg. Check your steps. Any doubts on this? Clear, everyone? I hope you're getting the hang of this question. So be careful when you see something going in a circle. It should be always with respect to that center. Clear with this? Perfect. Next thing. This is your top view. We have 3 identical spheres, M, M, and M. This is length L. This is a standard model, but we're going to modify the equation. Let's name them A, B, and C. So this is the top view. The center ball you kicked with speed U. So 3 identical spheres connected by strings are placed on a smooth horizontal floor. So there's no gravity and stuff. Now the ball B is given speed U. Now, if you leave it like this, what do you think will happen? If you look at the diagram, after some time, the B will come here, A will come here, C will come here, and after some time, B will come here, A will become like this, C will become like this. Are you able to visualize what is happening? As this is going up, it will start dragging A and C towards each other. Now, why does this happen? Because of this tension in the string. So because of this tension, B will start slowing down and A and C start accelerating. And if you see in this process, they start gaining speed. They start gaining speed in both the directions. They go up also, they go horizontally also. Means A and C are coming together. And eventually, when A and C collide, the system is going like ABC all become in a line. So the question is, this is the first part of the question. This will be a paragraph. Find the speed of velocity of ABC just before A and C collide. So A and C are almost touching each other. This is still a standard question you must have seen somewhere. Find the tension in the strings just before A and C collide. Is the question making sense, everyone? Is the diagram clear? Take a break. Come back by 7. We'll continue the question after that. Any doubt so far, you can ask me, or else come back in 10 minutes. Chalo, back in 10 minutes then. Come back by 7. Yeah, comes on you. Sure, let's give it a try. Hope the question is clear. So 3 balls identical, string length of the string is L and L. The center one is given speed U, A and C are not given any speed. So as B goes forward, it will start dragging A and C with it. So find the speed, velocities of A, B, C when the string becomes vertical and the tension in the string at that instant. U by 3. It's not U by 3. U by 3 for what? All the 3 speeds. All 3 won't have same velocity. Think, take a minute. I'll show you the speed part. Let's see. See. So this is your initial and your final state. You need to understand something. At this position here, this will have some velocity, let's call it Vy. This will also velocity Vy. This will also have velocity Vy. On top of it, this will also have velocity Vx, and this will also have velocity Vx. You're getting it? Look at this thing. Because of this horizontal component, A and C also are moving horizontally, right? And why is the velocity in the vertical direction same? They will have same vertical velocity because the string is tight. Since the string is tight, velocity along the string must be same. They have same vertical velocity. So if you look at A and C, they will also have a horizontal components. And that is a question, right? A and C are about to collide. That means A and C are moving towards each other. They do have some velocity. So just before collision, let the velocity be Vx. So we can conserve momentum. I'll conserve momentum in the vertical direction. You can conserve actually in any direction, but vertical we will say. Conserve momentum in y direction. So initial momentum, so P initial is P final. Initially only B is having velocity mu, now it is 3m Vy. So from there I got Vy is u by 3. Now what about the A and C ka horizontal velocity? Energy is conserved. Initial energy is equal to final energy. Initial energy only ball, B will have half m u square. Final energy half m Vx square plus Vy square. Right, this is for A. Half m Vy square, this is for B. Because if you see, the net speed will be Vx square plus Vy square. Half m Vx square plus Vy square, this is for C. So this is A ka kinetic energy, this is B ka kinetic energy, this is C ka kinetic energy. You already know Vy ka value, substitute here. That would be 3 by 2 mu square by 6.3. So we get Vx is equal to u by root 3. So the final speeds will be, this A is going up with u by 3 j cap. Horizontally, it is going u by root 3. B is simply going up with u by 3. It has no horizontal velocity. C is traveling horizontally with u by root 3 and it is going up with u by 3. Check. Those are the final velocities of ABC. So A and C will have horizontal velocities. Is this clear, everyone? This is still fine. It's a good question, but finding tension is actually a much better question. Now, how to find the tension in the string? That part makes this an advanced question. If this was a paragraph, I will ask you this only. Find the speed of A. So speed matlab, I will square it and add it. I think then it will be u square by 9 plus u square by 3. Then that would be 2u by 3 or something. I'll ask you that. Find the speed of A, and then I'll ask you find the tension in the string. Try. I'll give you a minute or two. How do you find the tension in the string? How do we approach this? Mu square by 3r. Listen carefully. There is a big trap here. If I ask you this question, are A and C going in a circle? In the ground frame, are A and C going in a circle? No, right? So who thinks A and C are going in a circle? B. Means if you go and stand on B, then B will think A and C are going in a circle. But if you look at this setup from the ground frame, B and C will never go, A and C will never go in a circle. Is that sentence making sense? The only person who thinks A and C are going in a circle is B. That means you have to keep the observer on B. This is A, C, and B. So my observer is standing on B. So if you stand on B, the relative velocity, you will see this is only having Vx. This is having Vx because Vy will get cancelled. Clear? Now there's a trap here. There's a catch. Look at this. Now, if I draw the FBD of B, on B, what are the forces? Tension, tension. So B is not at rest. B is accelerating. So 2 times tension is equal to mass of A into acceleration of B. This is a non-inertial frame. Now you went and you put a person on point B. So if you tell him to draw the FBD, what will he draw? This person will draw tension. Since you're standing on B, there will be a pseudo force. How much is that? Since the person is standing here, the pseudo force will be mass of the ball into acceleration of the B. It will be like this. This is your pseudo force. Till now, you didn't have a problem. You know why? The velocities were constant. At that point, the systems were not accelerating. But if you look at this point here, isn't B decelerating because of this tension? So if you put an observer on point B, isn't B a non-inertial frame? So you have to apply pseudo force. Since B is accelerating, there will be a pseudo force. Since B is accelerating, there is a pseudo force, which is mass of A into acceleration of B in the other direction. If you want to solve in the ground frame, right, you can't take centripetal acceleration because it's not going in a circle. There is a pseudo force. So this is a trap. And on top of this B things, now it is going in a circle. That is a different story. So we have a centripetal acceleration, or actually you can use centrifugal force also, but let's use centripetal acceleration, which is m vx square by L. So tension plus the pseudo force are providing the required centripetal acceleration. But what is MAB? 2t. So that becomes 3t. M, and what is acceleration? Vx square by L. And what is Vx? U by root 3. So what is tension? Mu square by 9L. Pseudo force also acts on a god. Where is your observer? On B. That is how you start, right? Just because you're accelerating, you don't put a pseudo force. Where is your observer? Observer is on B, right? So because of him, you keep a pseudo force. So you are asking B to draw the FBD of A, isn't it? Then A may what forces are there? Tension in the string, and one pseudo force, that's it. And B thinks A is going in a circle. So then you'll have a centripetal acceleration. Is this making sense, everyone? Quite a useful one. Again, you'll encounter something like this in rotational mechanics. Whatever we are doing today definitely should resolve again, especially all these questions, from this momentum conservation. From this question, all are literally advanced based questions. Any doubt on this, please ask me. Why there's a pseudo force, what is tension, what is that? Anything you're not convinced here? Most people, they forget the pseudo force. They simply write T is equal to MAC and they finish it off. And I was careful, look at this problem. In this problem, what did I do? I said when it has become vertical, so tension is this, so horizontally there is no acceleration, right? That's why there is no pseudo force here. On the ring, there is no horizontal force, isn't it? That's why there was no acceleration. That's why there is no pseudo force. Look at this problem. When it is in this position, there is no horizontal force on this thing, right? That's why there is no acceleration. If I had asked you the question, find the normal reaction here, this normal reaction will accelerate the wedge, then you have to apply pseudo force also. It becomes very complex to solve. So in the previous questions, I took care so that, I asked you the position where there is no pseudo force. But in this, you have to include. Next one. Any doubts on this? Next one. Top view. We have a ball of mass m. This is connected by a loose string. This is ball B. So we have a loose string of length 12. The distance between them is L. You're getting how is the picture? So two balls are connected by a string of length 12. but you kept them at a distance of L. And now what you did, you kicked the ball A with speed U. So what do you think will happen? After some time, the ball A will come here, string abhi bhi loose hai. After some time, ball A will come here. Now the string becomes tight. Now B will move, right? That means B won't move for some time. As long as the string doesn't become tight, B won't move. So the question is, A and B are connected by a loose string. Connected by a string of length 12. Placed on a smooth surface. It is irrelevant, Rabina. What will you do with time? कुछ है ही नहीं है time calculate करने के लिए. Alright, placed on a smooth surface as shown. So the question is, first one, find the velocities of the ball just after the string becomes tight. Second part, find angular velocity. So something happens, this thing starts rotating. Find angular velocity of the system after string becomes tight. And find tension in the string at that time. After the string becomes tight, find tension in the string. So if I give you this question, I'll ask you find omega and find tension, advanced paragraph. Get the second part. Try. I hope the diagram is clear, everyone. Velocity for both the balls is v/2. Nope. Velocities won't be same. Did you guys find the angle when the string becomes tight? Should I show you the picture when it becomes tight? See. So when this thing becomes tight, this length will be 12. This ball will travel horizontally. This is L. This angle will be 30 degrees, isn't it? That will be 30, or that vertical angle is 60. And this ball is traveling with speed U. This angle is 30. This is just before the string is tight. This is just before string is about to become tight now. Now I want you to ask yourself something. If you look at the components, this is u cos 30 and this is u sin 30. So when the string suddenly becomes tight, what will happen? The tension in the string will be along the string. Since the string is tight, this velocity will be, let's call it Vy. This velocity also will be Vy because the string is tight. Can you tell me what about this u sin 30? This velocity will remain unaffected. Why? Because the force acting is perpendicular to the velocity, right? If the force is perpendicular to velocity, velocity won't get changed. So the thing is u sin 30 remains same. Since tension is perpendicular to it. If the force is perpendicular to the velocity, it does not change. So when the string suddenly becomes tight, it will only mess up that u cos 30, u sin 30 is unaffected. Is that making sense, everyone? So if you consider angular, linear momentum along the string, to conserve momentum along the string, that will be how much? M into u cos 30 will be 2m Vy. So Vy will be u cos 30, which is u root 3 by 4. That's your Vy, everyone. So just after the string becomes tight, I will turn the page again. This is the scenario. This is M and this is M. This ball is going with u root 3 by 4. This thing also has velocity u by 2. And this is also going with u root 3 by 4. This is how the velocities will be. And how will the trajectory be? If you observe here, the center of mass, since there are no external forces on the system, the center of mass will go with v by 2 in a straight line. Since F external is 0, center of mass continues to go in a straight line. So it doesn't care what these two things do. The center of mass will continue in a straight path. They will just go in a straight line. And how will these two go? And these two will start going in a circle. So after some time, if you look at them, if I call this A and B, right? So this thing is going in a circle. The motion, it's going in a circular motion. It is rotating and going in a circle. We will talk about that, but have a look at this page. You're getting what happened? Because the string suddenly becomes tight and because both the masses are equal, this u cos 30 will share between them half and half. The u cos 30 becomes half for each, but u sin 30 is unaffected. Do have a look at this. Any doubts on this? Clear? Now, can you find omega? How to find omega? There is a much easier way. One is a long way, but one is an easier way. I taught you in circular motion. If I know velocity of 2 points, Then how do you find omega? Go back to circular motion. Do you guys remember this? Angular velocity of a particle with respect to another particle. What we do? Take the relative velocity perpendicular to the line joining by distance between them, isn't it? So if I know velocity of 2 points on a body, I can find omega like this. This is page 17, circular motion. So if I have to find omega here, it's V relative perpendicular to line joining by distance between them. So luckily here, the u root 3 by 4 will cancel. So the perpendicular velocity is u by 2 and the distance is 12. So omega is u by 4L. So this whole setup is rotating with u by 4L. This page 17. That is the fastest way to find omega. Another way to do is go and stand on the center of mass, then apply relative velocity and then do all that stuff. So you can find omega with respect to the center of mass, but it takes time. So you know how will your final question is looking like now? So this whole setup is looking like this, see. So we have two balls here, M and M. The center of this is your center of mass. This guy is just going in a straight line. He doesn't care about what is happening with both of them. This is just going with V by 2. How did I get V by 2, anyone? Look at the center of mass initial velocity, m1 u1 plus m2 u2 by m plus m, right? So initially one of them ka velocity is 0. So the velocity of center of mass will be mu by 2m, u by 2. Since there are no external forces, center of mass ka velocity will never change. It will just keep going in a straight line. These two balls are rotating with an angular velocity omega. So there, look at the motion there. So center is going in a straight line and these two particles are going in circles. So you want to find tension? Perfect. Go and stand at the center of mass. What are the forces? Tension. What is the force? M omega square R. What is R here? L, because this length is L and this length is L. So tension is equal to M omega square R. M omega is U by 4L ka square and R is L. Mu square by 16L. That is your tension in the string. So if you look at this whole path after some time, this is how this would go. So initially they're like this, A and B. They're rotating like this. So after some time, A will come here, B will be here. After some time, A will become like this, B will become like this. After some time, A will be like this and B will be like this and so on. They're going forward and rotating. The motion never stops. Please have a look at the steps. It's a good one. That's what I said. This makes this an advanced question, especially finding the tension part. And you should definitely try all this thing on your own again. When I'm explaining, you feel like, we are getting it. But if you really try to do this on your own, you want to try to do this on your own, you can do one thing, make this mass 2m. Just change one of the mass to 2m and then try to find the tension. That will be fun. Any doubts? Any steps you're not clear, please ask. Next one. Yeah. Able to hear me, right? Okay. Let's see. My Wi-Fi just crashed. This hotspot got connected. Let's hope it works. Next one. There will be a lag. So we got a wedge here of mass 2m. There is an m here. All surfaces are smooth. So this is given speed u, and this is height h. And this topmost point is a. So the first question is, find the minimum speed, find u minimum. Remember, when the block starts moving here, even the wedge will start going forward because the block will push the wedge. Find u minimum for block to reach A. So you just want to reach A to find the minimum speed. The second question, if you're giving u is equal to 2 times u minimum, the minimum speed, then find maximum height reached by the block. Right, maximum height reached by the block with respect to the ground. And describe the motion of the block. Is the question clear? I hope the question is clear, everyone. Have a look at this. I will just switch back to my Wi-Fi. Yeah, let's get this. So initially everything is at rest. So if you push that block M, as it goes up, it starts pushing the big wedge also. So this thing, if it reaches the topmost point A, so what is the minimum speed required to reach the topmost point? Second question, if I give you 2 times the minimum speed, then what is the maximum height you reach? And describe the motion of the block. Try. Just give it a try. I'll just get some water and come. maximum height with respect to the ground. So you understand what it means. Or you can say maximum height from the initial level. What is the first part, everyone? Root 3GH. Vihan, that's right. Try everyone. The first part you should try at least. 30 seconds more. I'll show you the first part. Then prove it now, you know. Exam whom will you go and ask all these questions? It will go, will it fly? Will the block jump there? Will it die? Matlab, right, solve. This is the whole information that you need. Let's see. Let's see. Again, always draw your final diagram. So when the block reaches here, now see, you're asking for minimum speed, right? Means it will just reach here and will come to rest. So there's no vertical component of velocity. Second, both the blocks will have same horizontal velocity. Why? If the blocks don't have same velocity, what will happen? Either the block and the wedge will get separated, isn't it? Or if the block is going too fast, the block will go into the wedge. Since they're touching each other, they have to have same velocity along the normal. Since they are in contact, they should have same velocity along the normal. So when the block reaches that vertical part, they should have same horizontal velocity. If they don't have same velocity, either they'll separate from each other, or the block will go into the wedge. They must have same velocity along the normal. Along the normal, not the total velocity must not be same. Along the normal must be same. Now be careful here. Vertically, there are forces. Normal reaction from the ground, mg, all these are external forces on the system. Horizontal forces are zero. So horizontal momentum is conserved. So horizontal momentum, P initial, P final. This is mu. This is mvx plus 2mvx. Because this is 2m. So Vx is equal to U by 3. Conservation of energy. Initial energy is equal to final energy. Initial energy, only the block has energy half mu square. Final energy, the block has half mvx square. And remember, the block also has got to a height h. So this block is at a height h from the initial level. Plus half 2mvx square. This is for the block. So block has both potential plus kinetic. This is for the wedge. But I know Vx is equal to U by 3. So substitute here and bring it this side. So half mu square minus 3 by 2 mvx square is equal to mgh. M gets cancelled. Vx is U by 3. That will be 2gh. 2gh, and this guy will be 2u square by 3. So you will get u is equal to root 3gh. This is your minimum speed. If you give this much, you will just reach the top and come back. Is this making sense? Now the second part of the question is saying you are giving double the speed. Now if you give double the speed, will it stop here? It will fly up now. So the question is find the maximum height from the ground level. Now can you try the second part? Try. I'll give you 2 minutes. And describe the motion of the block. After leaving the wedge, it flies up. How does that move? That's a pretty nice one. Think. Try. I'll give you 2 minutes. If the velocity is double than this, you won't stop at A. You will continue to go ahead. So find the maximum height from the ground level and describe the motion of the block. IH, no, Vihan, that's not right. Try. Let's see. But Daksha, when the block flies up, do you think the wedge will be at rest? You said something interesting. You said really something interesting, but you didn't realize. Puroja, you forgot to add the initial height. Unfortunately, exam में दोनों options होगा. After doing so much work, you'll mess up for that reason. That hurts more than actually not solving the question. So let me draw the diagram again. So this was the initial situation. Now remember, you're giving 2 times the speed. So u is 2 times root 3gh. Then you will reach this point A. But now you will also have a vertical component. You will have a horizontal component. The wedge also will go with horizontally because the velocity along normal must be same. So now if you try to conserve energy, initial momentum is final momentum. Mu, this is m, this is 2m, this is 2m is equal to 3m vx. So this story is still the same. Horizontal momentum is conserved, u by 3. Now if you try to conserve energy, half m u square is equal to, now the block will have two velocity component, vx square and vy square, plus the potential energy mgh, plus the wedge ka kinetic energy half 2m vx square. This is your block ka kinetic energy plus potential energy. This is your wedge. So this is half mu square minus 3 by 2 mvx square minus mgh is equal to half mvy square. Substitute everything that you know. So 3 by 2 u square by 3, that's u square by 9. This guy would be mu square by 3 minus mgh is half m vy square. But I already know what is u. U is 2 into root 3gh. So I get vy square is, how much is this? M will cancel. So u square will be 4. 3gh by 3 minus gh, this will cancel. Vy square is 6gh. This is your vertical velocity. Now, this is where something interesting happens. Now, if you have a vertical velocity and a horizontal velocity, what will happen to the block? The block will fly like a projectile, right? The block moves in a projectile motion because it has both horizontal and velocity. When it leaves contact, it has a vertical component and a horizontal component. Block moves in a parabola. It becomes a projectile motion. But something interesting happens now. When this block is about to fall, what is the speed of the wedge Vx? What is the speed of the block Vx? That means as this is about to land on the thing, the wedge will be there to catch you. Is that making sense? Because the wedge and the block have same horizontal velocity, every time the block is here, the wedge is right below it. You're getting the diagram? They both will travel same horizontal distance. So when the block is about to land, the wedge will be there to catch you. And the block lands on this. So when you land, you will have the vertical velocity Vy. This will be still Vx and this will be still Vx. Is that making sense, everyone? Since the block and wedge have same Vx, the block will land on the wedge. So the wedge is always right below the block. There is no horizontal relative velocity. And in this path here, this is your Hmax ka formula, which is Vy square by 2g. Vy square is almost 6j, so this is 3h. So from the point of contact, you will travel 3h more. So what is the total height? So total height is h initially from the ground level, plus you'll go another 3h. 4h is your answer. Is this making sense, everyone? So they can ask a question like this: for how long the wedge loses contact with the block? The time of flight, isn't it? 2Vy by g. So you can ask a pretty nice question based on that. Do have a look at this. Anyone not clear with the process? Anything that you didn't understand, not convinced, please ask. Clear with this? There, you can see how these questions are. This last test was really last 5-6 questions, right? This is what happens. You have energy conservation, you have momentum conservation, and you have all this stuff. So that is the last one for the day. So next class, when we catch up, we'll continue from here. We will do more problems on this momentum part, and then after that, slowly we'll be entering into collisions. But next class, we have even some more good problems. We'll bring springs into picture now. I know you have been missing springs, so we will call springs also. Let them also have some fun. Okay, with that, we'll wrap up for the day. So any doubts, anything, you can stay back and ask. Also free to leave. We did almost 29 questions, so please make sure to do it. In case you're doing HCV or some booklet, you can start doing it. You'll be able to handle now at least till momentum. Okay, those are out, stay back and